Good afternoon, everybody. Welcome to this session of the Defense and International Security track. We are happy to have you all here in our real meeting room and also the people who are joining us through the virtual session. Welcome to this session, which is all about the technology showcase. And I will be introducing the different speakers, and then after that there is a possibility for questions and answers if you have any. So the first speaker is Mr. Emlyn Hagen, who is a senior manager at L3Harris Geospatial, and he's just said to me, I'm a geographer and I'm very proud of that. And so I think that's the best introduction I can give to him. Please, Emlyn, take the floor. Thank you.
Good afternoon. So I'm Emlyn of L3Harris. I'm going to talk a bit about SAR for defense and security applications. If you're from a different sector, a lot of what you'll see here is transferable to other domains, let's say disaster management, natural resource management. And I'll simply show some basic, not basic, but some examples of this SAR. For the ones who are unfamiliar with L3Harris, L3Harris is a global aerospace and defense company with, I think, the 6th largest defense company with about 50,000 employees. And within the maritime sphere, we're the ones that provide the AIS or secure AIS signals globally. L3Harris Geospatial is best known for the software Envy, which is one of the leading imagery software packages, especially in the hyperspectral domain. It's been around for about 30 years. We got a few 100,000 users. Now, this is about SAR, and with our software SARscape, we're actually the commercial as well as the technological market leader within this sphere. Hence, and that brings us to the topic. And what you see here in the background is already a SAR image of Capella Space, which is a very nice constellation. When it's fully deployed, it's gonna be will give you imagery every hour around the globe. This is actually an image of Rotterdam. It's a synthetic SAR image. Now, there's lots of other players on the market. Each of these SAR sensors that have launched over time have unique properties. Some can look through leaves, some SAR signals can even penetrate the soil and give you information on soil moisture content. And these are just commercial ones. We also support quite a few of the military ones. Now, although you might have seen quite a few examples this morning from maritime as well as from Umbra, that's a 15 centimeter resolution SAR, that's impressive. What's the main benefit versus optical? So here on the left-hand side, there were some forest fires in California. You can see that clouds do, well, it's a bit of a challenge for forest fires, for smoke, be it from fires, be it artificial smoke in military operations. It's a bit of a challenge. Now with SAR, on the right-hand side, you can see that you have these, the agricultural fields are changing because things are growing, people are harvesting, and SAR can simply look through rain, clouds, smokes. And of course it works day and night, which is generally a challenge for optical imagery. So what are your typical applications for defense? You can detect minute changes between images. So let's say you have a desert environment and even with a low resolution image, let's say a 5-10 meter resolution image, if you have large trucks moving around, traversing your desert, because they move the pebbles and the rocks, you can actually detect those changes automatically in SAR. So with SAR, although 15 centimeters is very impressive, resolution is just one part of the equation. Detecting changes over time and monitoring moving objects you can detect. A classic example is ship detection. Monitor underground movement. So if somebody is constructing a tunnel beneath the city of Amsterdam, the chances are quite high that we can actually detect where this tunnel was built from outer space, because the buildings beneath the tunnel are moving up or down a bit. You can use it to monitor critical infrastructure, generate high-resolution DEMS, and today quite a few examples was given, but deforestation, also in conflict zones, deforestation is a big issue. Detecting floods, that also hinders your operations on the ground. A classic example is ship monitoring. Here, perhaps you heard it in the news, there was a small mishap in the Suez Canal where ships started to accumulate in the Red Sea, and with SAR you can detect these ships. And you might be wondering, well, all of the large ships, they have these AIS sensors on board because they're legally obliged to. Doesn't mean that they always have them activated, and that's what we then call so-called dark vessels. And SAR can detect these ships automatically. It's not a very complicated technique. It's something we do, however, very well. A bit more of an example here. So here you have your single SAR scene. We're now at the port of Djibouti. And when I overlay this with my AIS data, the yellow diamonds indicate areas where there was a ship and an AIS transponder active. The red circles indicate where there's only a SAR signal. Those are the ships of interest, because what's going on there might be a small fishing boat, might be something more nefarious, or let's say a military vessel. And you might be wondering, how often is that an issue? Well, we're now in front of the coastline of Tripoli where we track vessels. And you can see in March, there's an unusual high spike of vessels that we suddenly detect. It's certainly something that you want to investigate from a monitoring perspective. Now, how many of these, generally in Tripoli or for the coastline of Libya, have their AIS transponder on? Well, 10 to 20% have it switched on. So 80 to 90% of your vessels go undetected. Hence the need for SAR. Still, if these are a bunch of small fishing vessels, who cares? Well, and I'm showing you low resolution examples unlike Umbra, because SAR is complicated. So if we start with low resolution cargo vessels, look, that's a 12-meter resolution image. That's for somebody unfamiliar with the domain, difficult to interpret. But using deep learning, we can quickly train the models to tell what's a shipping boat, what's a cargo vessel, what's an oil tanker. And as soon as you have better models or high-resolution imagery, you use different models. And this all works quite well. Now, more towards the military domain. So there is all around the ports around the globe, shipping ports, missile defense site, airports, lots of times around military sites, you have radio frequency interference. That's these types of anomalies you see in your image. And you can see that 2 ships were detected. Is that a real ship? Oh, and my colleagues are very proud of that we have actually a lossless filtering technique. And when we apply this, you see that the vessels have disappeared. When we then combine the AIS signal, we notice that this ship over here does not have its transponder on. But if we look at the radio frequency interference, this is likely the source of that interference. Who knows for what? This is still Libya. Staying within the same domain, we are now at Aden in Yemen. And you see radio frequency interference over the city of Aden. We track that with the freely available Sentinel-2 data, I think. Yeah, yes. And we look at the ascending and descending orbits. And this is interesting, well, because when we combine all this information together with the bit of ground knowledge that we have, but we can pretty much pinpoint that's the source of your interference. Oh, and that's where there also be used a missile, form a missile camp. So that's likely for ground-to-air missiles, or perhaps for hostile aircraft tracking. Another example was we're now back in Libya. This is an airport tracked with Sentinel-2 imagery. And it's difficult to see what's happening here. And this is an airport that's defunct since 2011. Now, when we monitor that airport, these installations are monitored continuously. We can actually see that in 2019, the fence parameter is being constructed at these days. The red was in May, green was in June, and blue was in July. Now, this is not something that your analyst investigates manually normally. Everything that we show here is actually being applied in the industry or within the defense realm, and elements like this are automated. So people simply, so this runs automatically, and every week you scan your sites, and as soon as you find these anomalies, it pings up, and then somebody takes up a high resolution imagery and investigates. But it shows you clearly what's happening here. Now we are in Iran. And here you see a satellite image of Fordo. That's where there's a uranium refining facility. And you see throughout the desert lots of tracks where vehicles have moved, and you can see that. Oh, it's very nice. Clearly identifiable. Now, in the desert, these tracks stay around for dozens of years. So are they being used? Yes or no? And when we use SAR for a coherence change detection, well, only the elements you see in black, those are the ones that are actively being used. So this road here, something is going on here, that is completely not visible within the optical imagery. But some activity is going on, and we know that here there's some tunnel entrances. Amplitude change detection, we're now in Syria during the 2014 conflict. Amplitude change detection shows you a bit where there's some activity. You can hardly see it here, but so you know something is going on in these areas. And amplitude change detection is a great technology for a variety of purposes, but when we add a coherence change detection over time, you can actually see all the colored dots where from an air raid over multiple dates, the bombs impacted, they create a shock wave, they destroy the coherence. So destroyed windows, moved tiles in the roofs, and that's what these colored dots show at various dates. This is quite useful. So here, now before you've seen quite a few examples of one or two images. From a single SAR image, if it's a high resolution SAR image, that does not really work with the freely available Sentinel-1. We can also detect moving objects, ships, cars, tanks, or aircraft. In this case, we're at the Riyadh airport, and we can see that this airplane is moving from the north to the south. And again, that's an automatic calculation. So when you monitor a hostile base, you can see where people actively moving about. Organizations such as the CTBTO or the International Atomic Agencies, as well as various defense and intelligence agencies around the globe, they want to know what's happening at nuclear sites. So when the North Koreans, when they do a nuclear test, with SAR imagery, you can actually detect the displacement of the Earth at the surface. Now, this is also something unique within our software, because this also works automatically. From that information, we can pretty well infer how strong the nuclear bomb was. In this case, it was almost 70 kilotons, and that it was detonated at a depth of approximately 1,500 meters. And that's, of course, quite useful to know. Circling back to Europe, we're now in Hungary, near Pax. There's a nuclear power plant. And so far, I haven't shown you an example of interferometric stacking. That means you look over time, every week or every few weeks, on how much the Earth is moving. And then up comes a map like this. Green dots means no problem. Here there's a few red dots. Is that something to worry about? Yes or no? Perhaps there's a subsurface river. Now, when you overlay this information on the critical infrastructure, let's say a hostile airbase or your own airfields, you also want to know when something is moving there, or at a nuclear power plant in this case. Here you have the satellite image, and when we overlay the SAR image, you see these nice two dots appear here. Is that significant? Well, that's exactly where your chimneys are. And we can see over time since 2014 until 2018 that these have moved up by about almost 20 millimeters. Is that an issue? Well, I'm not a nuclear expert, but it's certainly worthwhile to investigate. And these types of investigations, these triggers, they happen automatically. And in this case, they investigated. Nothing to worry about, was harmless, but it's worthwhile to know what's going on with nuclear power plants, hydroelectric dams, or, well, any type of military base. So to recap, I think from a military perspective, SAR is extremely important for your general change detection or surveillance. And of course, this is for widely needed in a range of military domains, airfields, missile defense systems, etc. Yeah, that's actually it from my end.
Thank you very much, Emlyn, for this overview of the possibilities of SAR. So the next speaker is Peter Baumann. He is the CEO of rasdaman, and he's also a professor of computer science at Jacobs University. Please, Peter, you have the floor, and you will talk to us about pixel-accurate access control on open standards geospatial APIs. Thank you.
Okay. Backwards, forward.
Yeah, that's backwards. Yeah.
Works.
High
So
tech.
this is the stick of power.
Yes, you have to speak in the microphone so that the people who are following us online.
Right. So now that I get official, I dare to talk through the microphone. Hello, welcome everybody, and thank you for giving me the opportunity of talking here. We've heard about SAR, and we've heard about and seen data behind. Now, I'm going a little bit behind the evaluation as such, and also the acquisition of SAR data, but about maintaining them and getting them when you need them. And here's an initiative that I would like to bring to your attention, that is the Earth Server Data Cube Federation. And on this as a hook, I would like to present a few facets which are relevant for an operative picture that actually encompasses the information when you need it, where you need it, from fixed and from moving devices. And so let's jump into it. First, a little bit about us. So we are from the academic area. I'm leading the large-scale scientific information systems research group at Jacobs University, where we focus on actionable data cubes. And that has led to a spin-off company, which has presented, goes by the name of rasdaman. So our main results there are exactly that technology that is also commercialized by the spin-off, and that has brought us into standardization. And so today I'm editor of the data cube standards in ISO and OGC, and also getting fingers dirty in Inspire. We have been engaged actually since quite some time. Here's a couple of NIAC studies and a project that is supposed to start still within this year. Let's see. So we have been discussing with the stakeholders what's relevant, what's important, and in particular, where are the gaps currently. So we talk about big data. We are not short of data. It's just that the way they look are really prohibitive. So I don't need to explain the details of these archives. We all know the pain that we get there. And that effectively prohibits that somebody who is non-expert in IT, non-expert in remote sensing, deals with the data. So what could we deal with? Let's think about atmospheric data. If we think about the atmosphere here, we have a notion of something like three-dimensional, X, Y, Z, plus time, so naturally four-dimensional. So what a mental model actually is such a data cube, but anyway, some multidimensional space. And so actually this is just natural. And therefore, in order to make it easier understandable for us, we also should present data in that way to the users. That doesn't mean that we have to change everything radically underneath. I'm talking about the way how to present these data to users and to tools. And then suddenly it gets so much simpler. We don't have millions of products, but we have one data cube for Sentinel-1, one for Sentinel-2, and so on. And this is what has been done with the Earth Server project as a European-funded project initially since 2011. Okay, of course that doesn't come by itself. Some work needs to be done. Who has done that work of data understanding in the past? Well, the users. They had to do it. So on the far right side. Actually today this is more and more pushed back to the data providers. And that makes sense because they know their data. They have the resources for processing and providing them. And by the way, why not do it once and for all? So actually we have a new paradigm that the data provisioning is done in such a view that users better understand, and by the way, which are also easier for programs to handle, because they don't have to do all this bread and butter business of reading a file, reading another file, swapping it out, etc. Okay, that is actually this homogenization step of bringing things into a homogeneous space and time, which in the end makes analysis-ready data a reality. This is a term coined by USGS, the Lancet team there, and it's widely used meantime. It addresses actually data and metadata. Here we focus on the pixels to homogenize them. And then suddenly we can design interfaces that do the same for one-dimensional sensor data, two-dimensional images, three-dimensional image time series, four-dimensional simulation data, so weather data, for example, and so on. Okay, and this is the principle that is pursued by the Earth Server Federation. We present these data that are lying around in the archives already as data cubes. That makes it easy then to do spatiotemporal analytics and also data fusion, combination of different data cubes, and in a total location transparent manner. That is, you don't need to know where the data sit. So you combine one data cube that is sitting on Mundi, close to Karlsruhe, with another one that is sitting at Kryodias, which is in Warsaw. And you just don't see that any longer. This is totally based on open standard. And no, you don't need to be a Python expert, but it's coding free. And by the way, it's open for code and data. So the data centers come together because they want to offer. Actually, it's also good for commercial offerings. So companies can have paid offerings in that federation. Everything forms a big data pool that has an open and democratic governance. Okay, so a few things we have brought together that we consider helpful. The one thing is standards. So use the open standards, and that allows others to tap easily whenever they have standards conformant clients, for example. The single information space is an important thing. And that is technologically powered by an array database system or data cube engine, whatever, which is a pretty fast one, as several benchmarks have shown. Zero coding was important, as I said. No, you don't need to be a Python expert or R or whatever you want to use. And that opens the door to have many clients, from very simple leaflet and to have NASA Whirlwind, for example, up to, yes, doing analytics in Python or using ParaView for visualization, etc. Now, just one thing about the technology behind, and that is about distributed processing. I mentioned location transparency. How do we do that? Well, if we take such an expression here that arrives at the server, then the server will optimize and analyze each query individually. In this case, we find out, okay, the yellow part we can do immediately because we have the data. Not so the orange part. But hey, we have a friend in the cloud that has data set B, so we just cut out a subquery and ship it over to that node. This is how we do cloud parallelization. And at some time we found out, hey, wait a moment, we also can use that to go to other data centers. And so the blue part of the query, we would ship to the blue house for processing there, ship code to data, and just get the result back for integration. The CubeSat up there, it's not a vision, it's reality. We have brought rasdaman on board CubeSat of ESA, and so this becomes a data cube engine, and that means we bring the processing to the sensors, and this way we can integrate them. And now this is where it gets interesting, also for a common operational picture. Hey, we can integrate moving devices. So the fighter airplane that takes pictures can deliver dynamically into the Federation. A satellite can deliver dynamically, actually pre-processed already on board. And this we can combine with climate data on Earth, with map data, etc., so that we get one single plane, which then again can be redistributed, for example, to moving devices out there in the field. Okay, this availability of data has prompted, we need to think about security, because the big data obviously should not be available to everybody. Here's an example from science. So the European Center for Medium Range Weather Forecast, they have long climate time series, which they offer for free, except for the latest 2 weeks. For these you have to pay. That is their business model. So actually we need to be able to protect inside such data cubes. And so there is a concept where authentication can be done locally, or in the Federation you might have a common identity manager that defines who are those guys they want to access. But the local administrator keeps full control on about what can these guys do, also in the Federation. And effectively, we can do a protection down to a single pixel level based on bounding boxes, based on masks, based on you name it. Okay, I mentioned this funny word behind. Rasdaman stands for Raster Data Manager, and this actually has pioneered actionable data cubes way back. It's the principle of a query language, which allows to ask any query anytime on the data cubes. And underneath, there is a massively scalable data cube management and analytics engine, which is operational on dozens of petabytes. And we have parallelized single queries over more than 1,000 Amazon cloud nodes, for example. Okay, with that one, I'm not sure where I'm in time, but I have a feeling that I should get to a conclusion. And so, yeah, I see a yes. Let me wrap it up. So Earth Server is a federation of data cubes that come from large-scale data centers like the European DASIS, and these act together forming one information plane where actually more and more get added. Still this year we will add a NASA server, and Euroc in Italy wants to join us. Whenever somebody is in the federation, it will become part of this location transparent get together where you can ask coding free. And now applying that to our security topic here in this session, actually this federation and other federations that can be built, of course, independently, can form a backbone for a federated mission environment where you do a rapid fusion on the fly from data that sit in data centers and also moving sensors that deliver dynamically to increase situational awareness. So from and to data centers, from vessels, airplanes, drones, etc., these data can be combined. Okay, and now if we have still a minute left, I would take the risk of showing you a live demo. Oops. If I don't throw down the cursor. So let me find a browser here. Oh, browser? Yes, I see one. Come on, be nice. Okay. So this is a website that we have built actually in the capacity of standards editor. We wanted to showcase data cubes and the standards of OGC in 1, 2, 3, 4-dimensional scenarios. There are lots of demos that is actually publicly available. I want to go into a specific one where we talk about federation. So the use case is we want to determine heavy rainfall risk areas, and the climate modelers gave us a query in the OGC WCPS language that looks like that. I cannot explain that, but I see that we use precipitation data and Landsat 8 data. We need to combine them. Okay, let us send the query, where's my button, and see what happens. So we get back a result, hooray, which is displayed here in NASA Worldwind, showing what has been generated. But more interesting is actually the path which this query has taken from here to around about Karlsruhe, where the servers of CodeDE sit. And then they had to ask back because they didn't have some data. Oops, we need to go and ask our friend over there in Warsaw. And they have the other data part, they process it and send back the result. We can send it also to Cloudflare directly in Warsaw. And now they reciprocally will have to, can I get it? Yes. They have to ask back with CodeDE in Germany because we have set up the data accordingly. This is, well, what we are seeing is just distributed data fusion. How long does that take today if you want to do such a thing? There are many, many steps that you need to do before you arrive at that result. Here, you don't see it. It doesn't matter where it goes. And that is the principle of location transparency and getting those data ready for mix and match. And with that, I would like to thank for your attention. Thank you very much. And hand back the cursor.
Thank you very much.
You have control. The famous look into infinity.
Thank you very much. The next speaker who will introduce his technology to us is Sergio Albani, who is Head of Research, Technology Development and Innovation at the European Union's Satellite Center, which is, if I'm right, in Torregon. Yeah.
So thank you very much. Good afternoon, everybody. First of all, I would like to thank you for having invited me to deliver a presentation within this event. And let me start with a very brief introduction on SatCen. SatCen, as you know, you for sure know, it's an agency of the Council of the European Union, and we are located in Torrejón de Ardoz, in the vicinity of Madrid, in Spain. And our mission is to support the decision-making and actions of the EU in the field of the so-called common foreign and security policy. This is a sort of foreign policy of the European Union. How? By analyzing data coming from space-based assets and collateral data. I would like not to spend too much words on SatCen as it is and in our operational activities. Well, I've been asked to focus on what we are doing from a research and innovation point of view. So we have a dedicated unit in SatCen called RTDI, Research, Technology, Development and Innovation, the unit I'm responsible for. And this unit has the mission, let's say, to support our operational activities by implementing new operational solutions looking at the whole Earth observation and collateral data life cycle. We are currently doing this by focusing on, let's say, 4 or 5 main work streams. The first one is related to new data sources. So here the idea is to identify and assess data coming not from traditional Earth observation sources, but from, for instance, high altitude pseudo-satellite, small satellites, constellations, to see how this data can possibly be inserted within the SatCen operational chain. The second work stream is related to secure satellite communication. So, for instance, currently at SatCen, we are gathering user requirements for the incoming YouGov SATCOM of the Commission program. Innovative technologies, so evaluating, all these words like big data, artificial intelligence, cloud computing, interoperable platforms, digital twin. So all this kind of technology to see again how we can make profit of them within SatCen. Earth observation applications, it is quite related to the presentation we just saw from you. That's basically how to exploit at best the Earth observation data that we have. And in particular, we are focusing a lot on SAR data, because we believe that, actually I believe that within SatCen this is not a full exploited, let's say, at best, and SAR data can provide, as we have just seen, a lot of value. And in particular, we are dealing a lot with change detection algorithms. I will show you some examples using Sentinel data, because initially, the Sentinels were not thought to be used within the security domain because of their resolution, while actually we demonstrated that we can do a lot of stuff with the Sentinels. All these activities are mainly performed within cooperative frameworks. So as you can see in the bottom of the slide, we are participating in a number of projects within the Horizon 2020, now Horizon Europe Commission program. So this is a good mean, to foster cooperation with academia and with the industry. And we have a number of cooperation agreements in place, for instance, with the European Space Agency, and we are also a participating organization with GEO, the Group on Earth Observations. Let me now move to why we are basically performing these activities. So what to us is the main challenge in the space and security domain. And to me, it's key to maintain at the state of the art the capacity to manage and exploit Earth observation and collateral data to timely, this is the first keyword, provide stakeholders with clear, relevant, and trustful information. And we are currently addressing this challenge from a number of different perspectives that I mentioned here: data, technology, and models. So for sure, data, we have more and more data coming from different sources and different formats, with higher frequency, better revisiting time. So we definitely have not only to manage this data, but also to exploit them. And fortunately, also technology is evolving at good pace, so we can use a number of technologies, starting from big data, that now it's actually a bit old, up to the digital twin Earth. That's the new word that we are currently using. To do what? To deal with the concept that I call here new security. That is basically, traditionally, security is associated, let's say, to a given scenario, so to a specific scenario with a selected area of interest in which you have to perform a sort of analysis. So it's a single analysis of a given scenario on a specific area of interest. While now we are moving more and more in multi-domain scenarios in which different domains that we were thinking not interconnected, now they are. Just to give you one example, climate security. So the impact of climate change on the safety and security of citizens. So climate change is exacerbating, a number of issues, for instance, the scarcity of natural resources, and this is having an impact on the safety and the security of citizens, for instance, generating migration. So there's these cause-effect relationships within linked events in a sort of multi-domain scenarios that we have to go and cope with in the coming years. And that's why it's important, to build on R&I and cooperation. So to maintain, let's say, the SatCen ambition and role at the forefront of the space and security domain in the EU, we have to invest in R&I and cooperation, and this is what we are doing at SatCen. And these are the main aim of our R&I activities, to enhance operational processes and capabilities through the assessment and implementation of the latest technologies, for instance, again, big data, digital twin Earth, artificial intelligence, to explore new application areas, just to mention, again, climate security or even health security, now so popular because of the pandemics. And of course, the main aim is also to extend the SatCen service portfolio, so producing new geospatial products and services. An important mean we are currently using for performing these R&D activities, again, is cooperation. And we are doing this with the Commission, the European Defence Agency, the European Space Agency, and with a number of relevant institutions like GEO, the Group on Earth Observation. And the idea is also to extend the SatCen support to relevant security-related political priorities and EU policies, and of course to cooperate with the industry, with academia, and of course with the final users to steer, let's say, the technological developments. Let me just spend one slide more on the cooperation that we are currently in place with the key entities in the space and security and Earth observation domain. Let's start with the Commission. So we are involved in a number of R&I programs, mainly in the Horizon 2020 framework, as well as in the space programs. Okay, I will not mention SatCen, as you know, is an entrusted entity for managing the Copernicus security service related to support external action. I want here just to mention 4 projects that we have currently in place that are, spacing from maritime awareness to GovSatcom to the usage of artificial intelligence techniques within the EU ecosystem. And the first one is dealing with the exploitation of artificial intelligence techniques for conflict pre-warning map. Within the administrative arrangement that we signed in 2018 with the European Space Agency, we are currently having a number of activities. We are implementing with this a climate security pilot, a large-scale pilot. We are dealing with a number of artificial intelligence for Earth observation applications that we are currently implementing with the Lab in the ESA headquartered in Frascati. Earth observation-based services, and these are a number of new services using EO and collateral data that we are currently working with the Telecommunication and Integrated Application Department located in UK. And of course, we are organizing with this a number of sessions, events, just to mention one, the Big Data from Space conference. Within GEO, the Group on Earth Observation, I guess that our most important role is leading the so-called space and security community activity. That is the only activity related with security in the framework of GEO, in which we are exploring new solutions and sharing resources with the different partners of this community, including by the others, ESA, the World Food Programme. Last but not least, I call here research ecosystem. This is basically the cooperation that we are having, apart from Horizon 2020 project, with industry and academia to assess latest Earth observation technologies in the security domain, and to see, for instance, how collateral data sources can be, again, used and be useful within the security domain. Just one slide to show to you some examples of R&I initiatives. So this is not results of operational activities of SatCen. We have some colleagues here if you want to talk with them about the real operational activities of SatCen, but let's move on again on the R&I side. So the first one on the top left of the slide is a multi-temporal coherence that we did over Beirut. You may remember the explosion in August 2020. So here, using 2 Sentinel-1 data, we have this. We performed this assessment. You can see in green and red the damages on the area. So it's a change detection using multi-temporal coherence on Sentinel-1 data. The second example, again, Sentinel-1 data. This is an interferometric one performed on the La Palma Island. So you know that some weeks ago there was this the volcano and all these earthquakes and so on. So here you can see the terrain deformation caused by these eruptions using, again, Sentinel-1 data. These two were 2 internal studies, while the third one on the top right, it was performed in a framework of an Horizon 2020 project called Better, and this is related to fire and barred area monitoring. So here we use the Sentinel-1 and Sentinel-2 data, so a sort of fusion of the two to monitor what's happening in a given period in the Amazonas, with the burning of the forest there. In the bottom left of the slide, this is an example of a study that we performed with the European Space Agency, with the PhilAb. And here we use the artificial intelligence techniques to detect linear features using, again, Sentinel-1 data on desertic areas. It was quite promising because, you can use this kind of automatic system, to identify features on that, of course, desertic area, so it's a specific one. In the bottom middle of the slide, that's a dashboard that we implemented to work with an event databases. So in a database in which you can have info related to conflicts, and to try, to somehow link these event databases with other variables that can be useful in the security domain. We perform this in the frame of the Global Earth Monitor project. Last example, a change detection. We implemented an algorithm in the frame of the Next.js project, an algorithm using, in this case, Sentinel-2 images. And we used this for performing this study some time ago. And this is a change detection using Sentinel-2. We use this to monitor the construction of the Wuhan, hospital that we all, I guess, remember in the pandemic, the full, let's say, pandemic period. Let me conclude with this slide. How we decided to sustain, let's say, all the outcomes coming from these R&D activities performed in a frame of cooperation, Horizon 2020 projects, and internal one. The idea was we implemented a so-called Geospatial data management platform, GeoDump, making use of innovative technological and architectural solutions. And the idea was to demonstrate through GeoDump the vast potential of working in a platform-based approach. We can also, as this platform at the same time has this concept of data, so we can insert new data, we can use this with the new technologies, and we can evaluate new models to us, of course, to be applied in the security domain. It could also represent a sort of prototype of a digital twin for security. And it will be one of the building blocks of a future SatCen secure platform that we would like to implement to better deliver services to our stakeholders. So just to give you some let's say, examples of the capacities of this platform. We can use this platform to share knowledge between Earth observation applications, developers, and EO users. We can use the platform to give access to heterogeneous data, for instance, Sentinels, but also very high resolution data in a short term. We use it to evaluate innovative technologies, to develop new algorithms, for instance, the one you already saw in the previous slide, to sustain R&I outcomes. So this is the most important part. So this is a sort of platform in which all the results of R&I activities as SatCen can be inserted. We can demonstrate these results and pass these results to operations. So there are actually services deployed here, used by our colleagues in Ops, of course, with some specific tasks. But it's a sort of environment on between of an operational and a pure R&I one. Actually, I had another slide. That's the real conclusions. Just a very brief wrap-up of what I was telling to you right now. That's basically, in a daily basis, we are evaluating security scenarios as SatCen to provide relevant insights to our stakeholders, that is, EU member states. But, as I was showing to you, new challenges are emerging from data, technology, and models perspectives. So, to me, it's key, to invest on R&I and cooperative activities. It's essential to face these challenges, and this is what we are doing at SatCen, with this aim to bridge the gap within the pure operational activities and what we can actually find on the market. This is actually my last slide. Thank you very much for your attention.
Thank you very much. Our next speaker is Alexandre, but I have not your... Alex, okay. Alex Costa, who works at the Institute for Research and Technology in Porto. It's the Applied Research Institute, but the full title of the institute, I need to have my speaking note for that. Oh, sorry. Thank you. So it is the INESC Tech, which is the Applied Research Institute in Portugal, linked to the Porto University. Thank you.
Good afternoon. I'm gonna speak about the HF radar on Hagen, which is an HF radar system to improve maritime emergency management. So a little bit about me. My name is Alex. I'm a researcher at INESC, and I've been involved in maritime projects for 4 years. So after watching some of the presentations today, I feel like a baby, but I've seen very talented people here, so I feel a bit small, but I'll do my best to present the work that we've done. So INESC is a research institution, non-profit research institution that deals with AI, robotics, and geospatial technologies. A brief summary of the presentation. First, I'm going to present a bit about the project Radar on Hagen, the principles of data sharing, and a bit about the spatial data infrastructure that's behind Radar on Hagen. It's actually a difficult name for me to pronounce in English, Radar on Hagen, but I'll try my best. So what is it? It's a cross-border ecosystem of high-frequency radar arrays, and it's sustained by a spatial data infrastructure for oceanographic data. It deals with interoperable data exchange standards, and it's collected by several real-time data sources. The purpose of the project, there are some factors like marine emergency management to ensure quick response to emergencies, such as environmental hazards or disasters. There's also the goal to help in maritime traffic, like supporting authorities, supporting shipping entities, and also resource characterization to characterize how many resources are in a certain location, how can we explore them and use them for example, energy production, renewable energies. And there's also the goal to mitigate threats to the coastal zone, such as observing erosion and how the coastal is progressing in its natural state. Sorry, I'm a little bit shaky. I'm not very used to presenting. Well, let's hope I can present clearly, I guess. So the platform uses and follows FAIR principles. So the data that's available on the platform must be findable, must be accessible, interoperable, and reusable. So for that, the platform uses standards to communicate and exchange data into published data. And those standards are mostly OGC standards, and it follows the INSPIRE directive. So it defines standards that makes the system interoperable. And we call this a system of systems. What this means is that when a client speaks the same language as another one, we can interconnect them to exchange data. This makes much easier to exchange and share data between different entities. So here we have a little funnel that represents how data is exchanged from the source, where it's obtained from the sensors. And I'll explain why is it a funnel. This is ordered in terms of accessibility. So when we collect the data from the sensors, they can come in a format that's not interoperable. It might be clear text, for example, and it might be the job of the data curators to curate the data, determine the quality of the data. And so that's where it's least accessible. And as we climb through the funnel, we come through the data sources, which are the entities responsible for making that data available. And then we enter the services, where the data is ready to be shared, and it's in a standard that can be understood by clients, by applications that can connect to this data and understand what's going on. So there's a little joke in my land. Well, my land, I call it the data scientist land. What's the best gift you can give a data scientist? Is it a puppy? Is it a pretty flower? No, of course not. It's a large, properly formatted data file. Because it makes things much easier to exchange and understand, so we can understand each other. So here are some of the standards that are used in Radar on Raia, OGC sensor things, SOS, Sensor Observation Service, and NetCDF, and some other standards for thematic data, WFS, WMS, and those who are more keen into the OGC standards, you'll see that there's two sensor observation standards, which are SOS and sensor things. Sorry, observation and measurements. So they're almost the same thing. Why are there two? Well, some partners like to keep like their standards, so it's a bit difficult to negotiate with them. So we have to keep some support for other standards. Sensor things is much, in my opinion at least, much more flexible in terms of developments because it supports quick data exchange in terms of web environments, and you deal with responses and data sharing using JSON, which is much easier in my opinion to deal with, to parse data much quicker. It's oriented for Internet of Things. When it comes to SOS, you have to deal with some XML encoded things, but that's just my opinion, of course. So let's go through what the spatial data infrastructure is like. So it supports time series, so it supports sensor things and SOS, and this is where we display data that follows a time domain. It provides also a feature for data quality, so we can determine if a section of data was curated correctly by a data curator, for example. If it's valid, if the sensor is working fine, it will be displayed as working correctly. Or if there are some data gaps, you will also be alerted to those data gaps. In terms of thematic data, we support also standards like WMS, and you can display thematic layer. We use maps such as Leaflet and MapTalks. And with this data, we can extract indicators. They can be statistical indicators or indicators that tells us how a certain variable is progressing. So for example, the sea level, pollution. In this case, there's actually, this one on the right is, for example, nutrient concentrations. I think this is north of Spain. I'm not too sure actually what the screenshot is. I've already forgot, but yeah. There's also this one, which is a topo bathymetry, which helps understanding how erosion is progressing in the beach sector. This is a beach sector in Portugal. And so I'm going to present the case study of Radar on Raia. What does it deal with? It deals with the northwestern Iberian Peninsula. So it's mostly an HF radar network on the north of the Iberian Peninsula. And the goal is to update and extend this radar infrastructure. So here are some pictures of the radars that have been installed, along with a weather station up there. And there's another one, and the seagull right there. And there's another one. Okay, so how does Radar on Raia publishes its data? It mostly uses threads to publish mostly NetCDF data. It uses GeoNetwork for cataloging platforms, sensing platforms, and data sources, and Frost Server for publishing observation and measurements type related data, so time series, time domain series. There was something else I'm missing. Okay, there we go. Okay, so here's an example of a a visual data set that's acquired by a radar equipment. So in this example, we just see the radial seawater velocity in meters per second. This is the type of data that we can acquire with these radars. So I'm gonna conclude. In conclusion, this platform is a cross-border ecosystem. We intend to update and extend this radar infrastructure along the Iberian Peninsula. And it's sustained by a spatial data infrastructure that follows easily data exchange standards. So these are our partners that we are working with. They are mainly from Spain and Portugal. And that's it. Thank you.
Yeah. Thank you, Alex. Please stay here because the format is that you sit here and that people can ask questions. So can I invite the other speakers too, please? Thank you. Well, one of them seems to have other duties or a train to catch. So Peter has not joined us here, but that's no problem. We have 3 very intelligent and very strong people who are ready to answer any questions. Now, I don't know if anybody in the room has a question for this purpose. Yes, please. You have to use the microphone. Yes, but you have to use the microphone for our...
Okay.
Thank you.
Can they hear me?
Thank you.
Okay, I have a comments for Alex. Alex, it's an advice from an old man. I actually started this symposium by a keynote. I have a 34 years of experience on the field. Don't ever feel that you are small. You are very big. What you did just now, I didn't do when I was in your age. When I started, and this is, I'm not only telling you, I did this in my presentation because I told everybody when I came into this geospatial world, I came with nothing. I'm an aircraft driver, I fly airplane. What you did just now is just brilliant. So don't ever feel small. You did a great job. And again, well done. And you're good.
Thank you, because it's really, I think it's the right thing. You all 3 did very well. Thank you very much.
If I may make a slight clarification, GWF was kind enough to make a LinkedIn
Meeting room or something.
meeting, some post regarding my presentation, and they said that you can use AIS and SAR for automated target detection. I wouldn't say that's the case. I talked about moving target detection, but please don't try to target ships.
Yeah, okay. Well, it's just a matter of words, I think. Well, I don't know if anybody else has a question. Yes, please. Can we get a micro? Okay, thank you.
Hi.
Please
thanks.
introduce yourself.
Oh, yes. I'm Sampo Savalan from Spatial. I was wondering about, you mentioned, Emlyn, about your experiences being applicable outside the field of security. I was wondering if there's any work with SAR and detecting volcano activity.
Yes, actually, there's quite a lot, and you also showed that in your presentation. And I think the La Palma study is, we also got involved in there. The Montserrat volcano outbreak also in Congo in the 2000s. So it's a well-documented field where there's a lot of SAR activity going on, both with the low-resolution Sentinel-1 for freely available data, and now organization like Capella and IceEye, you can actually see the lava flow, and using our software, you can then actually see the volume of material dispersed pre and after the outbreak, as well as all the damaged buildings, or where, and it's not just volcano outbreaks, it's also a lot for earthquakes, etc.
Is it feasible that we could forecast volcanoes in the future?
Not with SAR, but what you normally would do is all hotspots you would monitor with SAR and Sentinel. The ESA does that automatically, and then when something happens, perhaps you can. What people do is they place seismic sensors all around. With SAR, you can see Earth moving where there's no sensors placed. So that's, let's say, if you have a nuclear power plant or a hydroelectric dam, they survey it every year. They place perhaps 4, 5, 20 sensors. But with the SAR imagery, you can cover the entire dam. Now, it doesn't replace the surveyors or the sensors, but the three of them combined, as soon as one of them noticed an anomaly, it's worthwhile to investigate before something terrible happens.
Yes.
Thanks.
Yes, there's another question.
It's more related to answer your question. It's actually, I have seen a ground-based synthetic aperture radar, which is exactly related to measure velocities. And you can somehow predict movements, but this would be related to a very fast reaction. Then to have an acquisition from a radar image would be, regarding the acquisitions, they're not that often, or you have to follow the specific area, I guess.
Yeah. So maybe I can give an example too, because when we had the floods in the summer in Belgium and Germany, we used SAR data to have an image that could help us to calculate the extent of the flood at a certain time and the time series of the flood. Because of cloud cover, it was not easy to use any visual data, but the SAR data was very useful. And Vito, which is a research institute, worked on that data, and we are, of course, it's still, let's say, it's not something we automatically do, but we did it in this case, and we completed it with other information, so it was a very useful input. It was there, the resource was there, so we tried to use it as good as possible.
Yeah. If I may add, very often we see, let's say, a highway collapse or something, infrastructural damage, or perhaps an earthquake. The SAR is often applied by the scientific industry in the post-event. Something bad has happened, and we can prove, we can see it in SAR. The idea is actually, like with the nuclear power plant, that you monitor these critical bits on a regular basis, and the data is available at a low resolution, let's say for your highways. And then when you see a subsidence happening, that alarm bell goes off automatically, and that's why these systems should be automated and not be, operator-based, so that you can actually take preventive active or mitigate this. But very often we see it post-event, which is, of course, well, in the case of flooding, you can't really help. Of course, you can mitigate it, but it's let's say, a collapsed highway where people die, and that happened in the past 3 years. I know 3 examples where the study was made afterwards, but not pre-event. And you could clearly identify it. Look, something's bad's going to happen, and, well, nobody was looking at the data.
Okay. Any other? Yes, please.
I have a question, actually, to the two gentlemen here. On the, you've mentioned a lot about the newcomer on SAR, like Capella, ISI, and and the others. Compared to the classic, monsters, which is you use their data. How do you see the revolution or the change coming? And also for you as a user in the center, and are you moving towards these small companies and you think they are going to make a change, or you still think that the existing providers like Cosmo and like the TerraSAR and the other the Spain satellite and all that will be the? Thank you.
I'll start. Each SAR platform has its own advantages and disadvantages. With platforms like Umbra, 15 centimeters is very impressive, as well as Capella and ISI. it still needs to be a bit seen if you can do elements such as deformation monitoring or earth movements, infrastructural monitoring, to the high level of accuracy what a Sentinel, although it's 12, 15 meters, or a TerraSAR X or Cosmos SkyMet can provide. Because these platforms, their antennas, they move a lot. And that needs to be seen. But I think for the larger platforms, it's pretty similar as with the, let's say, cheaper optical satellites. If they have 4 bands and perhaps not very well radiometrically calibrated, it might be a cheap data set, lots of coverage, but it doesn't give you the insights of perhaps a more expensive data set, such as an 8-band digital globe data set. It's every platform has its own pros and cons.
Yeah, I fully share basically what you're saying right now. So each platform has pros and cons. And what we do as SatCen is, for the time being, we are actually not using so much SAR data, so we are more focusing on the usage of optical ones. But SAR data are more and more important, and we have direct access, because, you know, SatCen can access data through commercial providers or through governmental ones. So we have governmental agreements with Italy and Germany, for instance, that can provide to us direct access to this data. So the idea is to continue working on SAR data using this capability that we already have, but what we are doing is more and more exploring these new companies and these new capacities to see how they can actually be useful in very specific issues. So in an ideal world, what we would like to have is a sort of, you know, the possibility to use both kind of platforms and both kind of data accordingly to the specific situation that we want to go and analyze.
Okay. Anybody has another question? Well, I have one. I would like each of the speakers in a very short statement to say what of the other speakers' information that he gave triggered your attention. Where did you say, oh, I want to know more about that? So it's a difficult question, I know, but think about it, and I'll just go down the line. Yes, please. Thank you, Alex.
So I don't know much about SARS technology and imagery, so that's something that immediately captivated my attention. So that's something I'm gonna learn more about. And seeing the presentations today, seeing very ambitious projects, I think I don't know the full context of this type of imagery, but it seemed very interesting to me. So maybe this is something that already exists, but since I'm not inside this context,
yeah. But
well,
in this conference, there's people from very different origins. There's mapping agencies like me. There's environmental agencies. There's people from really Earth observation business. So that's why we come to such a conference to hear about things which we are not working in.
Yes.
So thank you for your answer.
Yeah. Thank you.
I would give my vote again to you. So I'm a bit expert in the domain, but actually what I'm currently doing at SatCen is to foster the usage of SAR data and to foster the usage of Sentinel data in particular for within the security domain. So your presentation provided us with a very good overview of the different capabilities that we can have. So to me it was absolutely very interesting to see all these examples. It's actually the kind of presentation that I would like to show, and also to my colleagues to let them know the full capacity of these instruments that you presented.
Yeah, many thanks to both of you. My compliments. But for me, what your project is doing with the radar, the coastal monitoring. Actually, there's a ton of AIF can be signals for ships can be detected from space, and there's also terrestrial-based systems at ports. And all of that data is often combined by commercial companies in our company to provide enhanced data sets. And now what you're doing on the Iberian Peninsula will certainly be for all these commercial players on the market as well as industry, a valuable data set, as well as, I guess, also Frontex, people who are very much involved in the maritime world to see what these technologies can bring. So that was fascinating for me to see. And I must say the linear infrastructure SAR extraction of the SAR data, that's something that perhaps this is well established. I'm not a SAR expert because my colleagues, Dr. Parra and Dr. Alberto Paolo Pascali are. But that's something that I would very much later on like to learn more about from you.
Yeah, actually, it was something quite new. We published on remote sensing, so it was it was something interesting.
Perfect, wonderful.
Okay, so.
What about you, the moderator? Can we get your view?
Well, yes. Well, I'm from the mapping world, from the mapping agencies, and when I was listening to these very interesting talks, part of which I know about, and part of which I said, oh yes, I knew that, but I forgot. So, and things which are new to me, I was thinking, it's a pity that there is still today a gap between the satellite and what the satellites call the in situ data. And I'm really, I think we have not progressed enough in that field. And so it's a challenge for us as mapping agencies, but it's also a challenge for you as spatial agencies to see how we can enhance each other and make each other stronger. And so in these events we had in the summer in Belgium, I was doing whatever I could to get data, images. We had planes flying at 3 centimeter resolution, so as soon as possible, so we could have all the data. And then I said, well, it never came to my mind as a reflex to see, and what can Copernicus do for us? And there is all this service, and I did not use it, which is shame on me. Shame on me. I j'assume, like we say in French. And then I said, well, why didn't we? Because it's not built in our system. And I think the same shame has to go on the space industry when they say, well, you know, we're not working with these old-fashioned map guys because they're too late. It's not what we want, and so on and so on. So it's strange that we are in the same industry and still we don't seem to connect. And I think that's really something I would like to take out of this discussion. I have to do more efforts to connect to what you are doing, and I hope that effort will be mutual. We have to have a data cube where we find each other. Thank you.